As you might know, we have BGP course starting today for the April 15, and this course will be 5 days in a row. We have another one, same course, but it's just on the weekend. Whatever which one is suitable for your agenda, you can join that one. So that's fine. So let's start introducing the agenda. Welcome to the class, by the way. And let me introduce myself for those who don't know me, if there is still anyone there. My name is Orhan. Most people know me through my CCD training, as you might know. Today we will start discussing the BGP from very basics, and you will see now the agenda up to the almost every new feature. With the BGP we will talk mostly from design point of view, of course, and some operational considerations also we will share with them. After 5 days, hopefully, you will be very comfortable, as I promised, with BGP. Okay, so sessions 3 to 4 hours I am considering. Some days might be a little bit longer than that, but entire agenda we will finish in 5 days, hopefully. Okay, we will start with very basics, BGP basics. Why BGP? We are using it. What is autonomous systems? Those kind of things. And BGP best selection algorithm. I will cover this topic at the very beginning. So because entire course we will definitely use many times BGP best selection algorithm. So after that, still we will continue with some basics such as BMP. BGP monitoring protocol, compare it with traditional CLI. I will introduce at that moment 3 different BGP database: BGP adjacency RIP-in, local RIP and RIP-out adjacency out databases. So, and correlation with BMP protocol. We will start after that with eBGP, external BGP, basics of eBGP, loop prevention, those kind of things. Then, since we will learn in the BGP best selection algorithm here at this topic, lots of BGP attributes. So in eBGP traffic engineering, we will be using those attributes for inbound or incoming or outgoing traffic engineering, inbound, outbound traffic engineering. So how we can send the traffic from our network to outside world, and from outside world, how we can receive the traffic to any of our co-location data centers, internet gateway locations. After that, still we will continue with some basics. There is a business relationship with the companies, with the autonomous systems, and most of the service provider networks today, they rely on Go export model, which I introduce here. And what is customer, what is provider, what is settlement free peer, and why service providers choose and which model, basically their default policy. But of course, depends on the SLA, depends on the customer requirement, and if customer is paying extra money, so service provider might be doing different policies, and we will be discussing those. Multipath is an important topic for BGP because with IGP protocol, OSPF, SAS, EIGRP, etc., when we have equal cost multipath, so for the same destination, so for the destination, if we have 2, 3, 4, 5, 10 parallel paths, cumulative cost should be same, then automatically ECMP next hop is installed into the routing table with BGP, even if it is same end-to-end IGP cost to the BGP next hop. We will not install basically prefixes with the multiple next hop automatically. We need to manually enable how eBGP multipath, IBGP multipath, and both IBGP multipath works. So if I receive the prefix from both external and internal BGP neighbors, so how we can do multipath in this case, what are the use cases for that, we will discuss, and even caveats for that. It can create routing loop, we will talk. After that long topic, we'll start with eBGP. We have interdomain routing. You might see a couple of this topic in this first page in some certification trainings, but you will not see in any certification training interdomain routing, settlement free peering. What is this concept? SFI, partial peering, remote peering, all this stuff, or IRU, IP transit, IPLC, those kind of service provider related, mostly, not mostly I'm saying, not all, of course, always. In fact, most of the settlement free peering is done between the content providers, CDN, and the service provider. We will be talking about those things. And I will introduce internet exchange point concept there, by the way. Let me see the second page. Yeah, although I haven't shown you here, We will be talking Internet Exchange Point, benefits of Internet Exchange Point, what is Internet Exchange Point, what kind of environment we are talking about. Then in the Internet Exchange Point, we have also, it would be too long, I didn't write all the course outline here, but we have concepts such as private peering, public peering, bilateral peering, MLPE, multilateral peering. We will discuss them, and I will introduce BGP route servers, especially in the public peering case, MLPE case, multilateral peering exchange. We will be using BGP route servers in, of course, in any IXP networks today. In real life, we have around 500, a little bit less than 500 Internet Exchange Point in the world, and they are using BGP route servers. And what is that? We will be comparing also with BGP route reflector a little bit, but at this point, I don't assume you know anything about BGP route reflector, etc. We will be discussing, you will see now in the agenda. So what is looking glass and route views, those kind of things will be covered here. And from also in the inter-domain routing space, so service providers, content providers, CDN networks, news agencies, mobile providers, edge computing providers, any of these basically networks, they participate in this peering ecosystem. And we commonly mentioned about ISP tiers, tier 1 provider, tier 2, tier 3 providers. What is this concept and how companies are categorized as tier 1, tier 2, tier 3? What are the benefits of being tier 1? Is there any global tier 1? What is this concept? We need to dive in, and we will compare also. At that moment, I will compare it with data center tiers, tier 1 data center, tier 2, tier 3, etc. You probably heard that term. Yeah, after that, we will start slowly IBGP, and it will be very long, probably longer than, I cannot say longer, both are very long actually. That's why this course is long as well. Every day 4 hours and 5 days, as I said. Full mesh IBGP, why IBGP in the first place? We have eBGP, cannot be continued just with the IGP protocol or SPF-ISS. I'm not talking scalability only. What is the real reason using IBGP? We will talk. And some IBGP dictated rules we need to discuss. Full mesh IBGP, why it's required, and how we can make it network design a little bit relaxed without BGP, full mesh internal BGP. What we can do, route reflectors and confederation. But before confederation, we will start route reflectors, and as you can see, different design options, lots of different categories of route reflectors can be designed, and such as here you see centralized versus distributed, inline versus offline RRs, POP-based versus placing in some data centers, those kind of things, IP versus MPLS RRs, and in different cases we have different considerations, guys. And that's why we will cover different design options, and we will see that route reflector will select, as any other BGP speaking routers will select only single best path, and it might be, by the way, in design, any choice. Whenever you have choice, you have always pros and cons, advantage and disadvantages. Okay, so we will discuss route reflectors advantages, also disadvantages. Different customers or different companies might be requiring route reflector to send more than one best path, and what are the available models for that, at path shadow or shadow session, those kind of discussions for the IP route reflectors. Then after that, when we have MPLS route reflector, what are the choices? And after that, comparison between all these models, comparison charts I created for you. By the way, this document is currently 512 pages, and for the weekend PGP Zero Hero course, I created a Dropbox folder because I think around 40-50 megabyte this one, but each day recordings also we will save in the Dropbox. So videos also you will be able to watch later on. So for you, I will create. Those who don't have Dropbox access, after the session you will ping me. So I will share invitation link for the Dropbox for you, so you can download the session slides from there, as well as later on you can watch the videos. Okay, 512. Why? That's an important number. I kept intentionally 512. Normally I want to add extra some slide, especially for the third or fourth page of the course outline, which is BGP LU dash labeled unicast RFC 3107, and also BGP link state, BGP LS. So for those, I need to add extra topics, but really, just I like this 512. We will talk about 512, a number, why in BGP it's important, etc. Let me continue to introduce agenda. So BGP route target constraints, how we can make it basically when we have the route reflector, more scalable route reflector design, and BGP after that optimal route reflection. So if I place centralized arash without EdPet, without any shadow arash, shadow session or unique RD deployment, how I can send the optimal route to the route reflector client, that will be important. So we will discuss that one. And optimal route reflection, as I said, will be our next topic. Just by the way, nobody is telling me, but I am not sharing my screen. Sorry for that. Please talk, and this session should be interactive. If you don't talk, it will be bad for me, and I will be crazy. So definitely give your focus and ask question. When I ask question, if you are listening, just if you don't know the answers, say that I don't have an idea, I don't know. But don't tell me, please repeat. If you don't understand, if it's because of maybe voice issue, etc., I can repeat. Just give your attention, please. Okay? So optimal route reflection, as I said. After that, confederations, BGP confederations, we will start. So how it works, why we are doing BGP confederation, when we receive the multiple paths from my intra confederation eBGP peer versus real eBGP peer versus iBGP peer within the subautonomous system, what would be the path selection, what would be the preference of the paths, those kind of design options we will discuss in BGP confederation. So when we finish that, we will be able to compare full mesh iBGP versus route reflector design versus confederation. And in real life, some networks which I am working with, they are relying on confederation design for multiple countries. They have an operation and they are using confederation. So better to understand that one as well. And I will show you case study. If you have full mesh iBGP network today, and if you want to migrate to the route reflector design based network, how we can do that. And continue. Networks is not just you run BGP. You have IGP at the same time, you have LDP maybe, you have MPLS, other protocols, maybe segment routing, all these protocols, and how they are interacting with BGP. Okay. So BGP IGP interactions, how we can avoid black hole when there is an unplanned and planned failure. Then BGP MPLS interactions, little bit going after this, some advanced topics, guys. After talking eBGP and iBGP, now we are starting some advanced topics. So BGP labeled unicast, RFC 3107 case. So there are some real life application for that, real life business driver, real life use cases, such as interface option C, carrier supporting carrier, seamless MPLS, unified MPLS. So that's why we need to understand BGP LU very well. And BGP link state getting more popularity. We are using in BGP EP as well, that one. So new NLRI, new address family for BGP link state. We will discuss that one. After knowing BGP LU and LS, they will be the key parts for the BGP egress peer engineering. Nowadays, more and more service providers, they are asking from us to send a proposal for their egress peer engineering. I will cover this topic as well. Traditionally, how people do traffic engineering for their BGP routers, IGW, Internet Gateway routers, and today with the controllers, specifically how they are doing that, what are the advantages of controller-based approach, centralized approach versus distributed traffic engineering. When we finish that, DDoS prevention and how BGP is used in the DDoS prevention space. So we will start with just filtering, basic filtering, and then we will continue with more dynamic approaches such as RTBH, remotely triggered black hole, and source destination based. We will talk about scrubbing, we will talk, plus after that RFC 5575, BGP flow spec, the IETF effort, for the last IETF effort in this space, and how it works, what are the advantages of BGP flow spec compared to RTBH and disadvantages. Whenever there is an advantages, we have disadvantages as well. Of course, this is not also last. we have many other topics. BGP session calling and especially usage in the Internet Exchange Point, IXPs, and some alternatives other Internet Exchange Points use, such as optical, cross connects, etc. We will talk. Most people confuse graceful restart with graceful shutdown. Maybe some people are aware that BGP graceful shutdown is available for packet loss prevention, let's say, in case of IGW router replacement or planned failure cases, etc. Planned failure cases, how we can reduce the packet loss or reduce it to zero. So with graceful shutdown, and what is graceful restart, what is administrative shutdown? I think this is currently that topic we are discussing we discussed in the last weekend BGP 0 course. So probably Wednesday we will finish that topic as well with you. So we finished third class with them. So AIGP, accumulated IGP metric, why it is used, and what's the use case for that. We will compare after that with BGP MET. After that point, we are starting mainly security and BGP. So BGP security, we can say. So RFC 8212, EBGP default route propagation behavior, we have a new RFC for that. And after understanding why it is necessary, we will look at 6 different type of route leaks. So in BGP information security, what is route leak? BGP route leak is critical topic. Yesterday, I was sleeping, and when I woke up, my wife told me, yeah, Facebook, WhatsApp, lots of services were down. I said probably hijacks, and I didn't check what was the real issue, but it seems that targeted attack, something happening. So really, by using BGP, and nowadays we are seeing more and more attack by using BGP and stealing Bitcoin. Maybe you recently seen that, and lots of things happening. We will deep dive BGP route leaks, BGP information security, sub-prefix hijack, prefix hijacks, then what are the prevention mechanisms, IP squaring, path shortening, lots of attacks we have by using BGP, and how origin validation, path validation, RPKI, BGP those protocols can help to mitigate this issue. And I think this will be the last. So BGP mainly designed for the wide area networks, as you might know. But today, we are using BGP for both services and transport in the data centers as well. BGP in the data center, probably you heard this topic from Microsoft, LinkedIn, Twitter, all these guys used Facebook in their data center for transport, so carrying their server subnets, BGP. And it was defined in RFC 7938. We will deep dive there. Why not IGP protocol? Why not layer 2? Why layer 3 in the first place? And if it's layer 3, why not IGP? What were the requirements for BGP? If it's BGP, then is iBGP or eBGP better? So if it's eBGP, then we will come to that conclusion. Okay, what are the considerations with eBGP in the data center designed for transport? For services, also BGP can be used, and we have eVPN for that. And data plane can be VXLAN or any other technologies. VXLAN eVPN nowadays mostly discussed for the BGP in the data center as a service protocol. But mostly I will discuss transport protocol. If it's eBGP, as I said, what are the considerations such as 2-byte ASN, 4-byte ASN? If it's 2-byte ASN, what is the ASN allocation schema for closed networks, 3-tier, 5 tiers, 3-stage, 5-stage closed networks, FAT3 networks? What should be the ASN allocation schema on the top of rack, leaf, and spine? So, and of course, during this BGP data center discussion, we have so many subtopics as well, such as we need to understand convergence, we need to understand BGP path hunting process, what is path hunting, and what is the correlation between path hunting and the ASN allocation schemas in eBGP. So that's why, as I said, after second page of the course outline, it will be advanced topics. Yeah, for the first 2 days, you might enjoy a little bit, but after that, you need to suffer. So BGP in the data center will finish, and we will start BGP in the wide area networks. Mainly, it was anyway wide area network, and we will highlight why, and etc. BGP peak, so we can consider as BGP phase convergence. Some people FRR as well. I will define the differences between FRR, phase 3 route, and the phase convergence. And so for the BGP peak, prefix independent convergence, before that, we need to understand how flat versus hierarchical versus generalized FIB architectures, three different FIB architecture, hardware architecture on today's routers. By designing different FIB architecture, how we can have BGP prefix independent convergence, and how hierarchical FIB architecture can help for the BGP peak core concept. Because with BGP peak, we will see two different models, two different protection, let's say, peak core and peak edge. So hierarchical FIB architecture will help for the peak core, and the generalized FIB architecture will help both for peak core and peak edge. We will discuss. After that, we have many case studies. If we have time, I will cover these case studies. Otherwise, we will have a look. We have many of them, like I think 6, 7, 8 different case studies. And still I am discussing, like one of the case studies, as I remember, BGP best external feature. Although there's a case study I need to discuss at some point, probably during BGP EdPad shadow ORR discussions. I will talk about BGP best external anyway. And also another case study. When you download the session slides, you will see them